Hi there, I'm Ben the Tutor, and this is discussing a kinematics problem. And this is actually a kinematics problem in 2 dimensions. If you're doing physics in grade 11, you will see lots of problems like this. Let's talk about it. Okay, a ball is thrown off a cliff at 10 meters per second with an angle up of 20 degrees. That means the ball is being thrown upwards like that. So you can imagine you're standing at the edge of a cliff and you throw a ball up. And so it's going to go up and then loop down. So it's going to travel like something like that. Woo! The ball is in the air for 5 seconds. How high is the cliff and how far does the ball go? So there's 2 questions here. How high is the cliff and also how far does the ball go? Now, this is a 2-dimensional question. Some questions are 1 dimension, which is like being thrown straight up and down or going in a line. But this has a x and a y component traveling in an arc. It's 2 dimensions. And when we're doing these questions, we have to do separate equations, ones for the x dimensions and ones for the y dimensions. And we have to deal with them separately. And we've started with a velocity, which is at an angle. And so the very first thing we need to do is think about the velocity as in components. So if I redraw a vector of the velocity in 2 components, this is the velocity initial, and that's, I did say 10 meters per second. So this one is the x velocity, we call it vx, and this one is the y velocity. This is a triangle with 20 degrees. And so we need to use normal kind of trigonometry stuff. So we think about SOHCAHTOA. So to find Vy, it's opposite, and I have the hypotenuse, so I need to sine. So sine 20 degrees equals Vy over 10. So Vy equals 10 times sine 20. If you put that into your calculator, you will get 3.42 meters per second. And the other one, Vx, is cosine. So the x is the adjacent, and the hypotenuse is the one we have. So I need k, adjacent hypotenuse, cosine 20 equals Vx over 10. Vx equals 10 times cosine 20. And that is 9.36. Okay, so now I have the speed, and this is the speed along the x direction. That is the x component. So it's traveling horizontally at that speed, and this one here is the vertical speed, so how quickly it's moving upwards at the beginning. Now, we can do these horizontal one and the vertical one separately. Let's just start with the horizontal one. So for kinematics questions, we start by listing the things that we know. In the horizontal direction, what do we know? Well, the x speed is 9.36 meters per second. And that's the initial, Vx initial. The final velocity, well, let's think about that after we think about the acceleration. Now, this is a really important step. We've learned that the acceleration due to gravity is 9.8 meters per second squared, and that's correct. However, the horizontal guy is not accelerating at 9.8 meters per second. The acceleration is actually 0. Now, this is confusing for some people, because when you watch a thing be flying across the sky, it's moving real fast, and you see the speed changing. But if you think about it, there's no force acting on this guy in the air. There's nothing pushing it. And you remember from Newton's law that the force equals mass times acceleration. That is, if the force is equal to 0, then the acceleration is going to be equal to 0. So this final speed along the horizontal direction is the same all the way through. Now that's not true for the vertical speed. That will change because of acceleration, but just for the horizontal speed. So the v final equals 3.6 meters per second. Now the time is 5, and the distance is what we're looking for. Now, kinematics questions mainly apply for things that are accelerating. And this horizontal guy questioning, he's not accelerating. So actually, we can use a very simple equation. The velocity is the distance over time. We can use this because the acceleration is 0. If the acceleration was not 0, then we'd have to use the normal kinematics equations, which I'll use for the vertical in a second. Okay, so I have v equals d over t, so the distance is the velocity times the time. And if I plug this into my calculator, just looking for my number, it's 48.6. My secret notes are down there in case I forget how to do something. So you plug in 9.36 times 5, and you get 46.8. So that is the horizontal 46.8 meters. Okay, so how do we figure out the vertical? We do the same procedure. We start by listing the initial velocity, and that is this 3.42 meters per second. Okay, velocity final we do not know, because the vertical velocity is changing as it accelerates. The acceleration is negative 9.8 meters per second. It's negative because it's pointing downwards. The time is 5.0, and the distance is what we're looking for. So we have 4 things. The thing that we don't care about is v final, so we need to find the kinematics equation that has nothing of the v final in it. And that's this one, d equals vit plus 1/2 at squared. There's no v final in this equation. So I now plug all my information into the spots here. So d is what I'm looking for. 3.42 times 5.0 plus 1/2 times negative 9.8 times 5 squared. And if I put this into my calculator, I get negative 105.4 meters, which means 105.4 meters downwards. And I probably need to round that to negative 110 meters. Okay, so this is a 2-dimensional kinematics equation question. And probably using this equation is the hardest step after we've done the components of the velocity. Thank you very much for watching.